homework 2-1 was part of the homework for yesterday. Like, it wasn't actually assigned, but it was available for you. So it was up on Digit. So you may have already started it, or you may have not. If we get into 2-2 today, 2-2 is already assigned as well. It's up live on Digit. You can do it. But my hope is we can move quick enough through some of these lessons that we end up with time for a work day. That I can give you guys some time so that I can help you and everything else. So 2-1 and 2-2 if you have a chance or you're able to do it. Yeah.
Why don't we wait? I don't. You don't have to do this, but why don't we like take laptops out and then why can't we just do two together?
Because we need to learn it first.
Okay.
We haven't learned any of the chapter 2 stuff yet. So that's like my goal is that we would get through the material so that then we can have a class day where we get it out and like you guys practice and I can help you like we did last week. You know what I mean? Yeah. So that's the goal. So what does it mean for two things to be proportional? So here we've got an example with a carbon. Very fitting that I'm in purple today.
Wow, our powerful purple paint sure is popular.
Yeah, I know. I'm getting all sorts of orders and I don't know what to do.
So, who's in art here? Like drawing art? Yeah. So when you mix color, there's really only 3 colors. Like, there's really only 3 colors. All other colors, yeah, it's the primary colors. All other colors are mixtures of those colors.
Really?
Yeah. So, to make purple, all you do is take red and blue and mix it in the right ratio. If you get the ratio wrong, it will look gross. So,
Purple, green, and orange are part of the secondary.
that can be made with primaries, yeah. And then you can use the secondary colors to make, yeah, it goes further and further. Yeah. Very cool. Are you in art or do you use, okay. So, we have this relationship. So if they wanted to make 5 gallons of purple paint, they would use 2 gallons of red paint, 3 gallons of blue paint. If they wanted to make 10 gallons of purple paint, they'd use 4 gallons of red, 6 gallons of blue. But does anybody know what it actually means to be proportional? Like if I told you the swimming pool's depth is proportional to how long we've been filling it.
Related to?
Related to, yeah. Directly related to, actually. We can throw that directly word in there. What if I went further and said the swimming pool's depth increases 2 inches every hour? Like if you were filling it, the pool was really, really big. So after 1 hour, how deep would it be? If I said 2 inches every hour.
Four.
Ah, but we've only gone 1 hour. Two. So what about after the second hour?
4.
After the third hour? After the fourth?
8,
So,
10, 12, 14.
hey, yeah, we know the even numbers. So that is an example of a proportional relationship because any of those fractions, if you took the depth of water divided by the time, you get that 2-to-1 relationship. Look at our table right here. 2 gallons of red paint, 3 gallons of blue paint. I can set up 2 to 3, red to blue. I can compare that to my 4 gallons and 6 gallons. Would that reduce to be 2/3?
Yes.
Yeah. What about 20 to 30? Would that reduce to be 2/3?
Yeah.
Yeah, and what about 40? If you can see that at the bottom, it's 60. So 40 to 60, I could on top and bottom divide by 20.
Just take off the zeros and then.
I could just take off the zeros and then divide by 2, right? So, since all of these end up with the same reduced fraction form, that means it's a proportional relationship. So what we need to see is that reduced fraction form being equal for every single part of the table. All because the first 3 parts work, you still have to check the fourth. There's no point where you can say, oh, we don't need to check that. You got to check every single row of the table. Alex? I know this is the launch. You guys don't have this, but you do have. So on your notes,
This isn't our notes.
it is, except now it thinks I'm highlighting.
Oh,
You have X and Y. Now on your notes, the hole punch chopped through the X. So right above the hole punch, I want you to write X. That first top hole punch there, it chopped through the X, so I need you to write X there. I need to adjust my margins. We're on the front. Todd, you see what we're talking about? On the front. where this right here, the hole punch chopped it out.
Oh.
So write x either above or below the hole punch. So x and y have a proportional relationship if y is always a multiple of x. And actually, here's what Haley just told us. This is what we call direct variation. They vary together. One relates to the other. If things are not proportional, we call that varying indirectly. So say if you were like filling up a container, but it wasn't like a cylinder, say it was really small at the bottom and really big at the top, that would not have a proportional relationship, because if you fill it, it'll slow down as you go to the top because it's wider and wider and it takes more and more water. So that would be indirect. So when we look at this table, sorry, do you have a question?
No, I was just confused.
So our key concept here, so you can visualize it. If we
Two
start
quantities,
two
x and
circles
y,
and
have a
one
proportional
square,
relationship
we have a
if y
relationship
is always a
2 to 1.
constant multiple of x.
If we then
A relationship is
turn our
proportional if it can be
relationship
described with
into
equivalent
4
ratios.
circles,
When there
how
are two
many
circles,
squares would
there
I
is
need?
one square. The ratio of circles to squares is 2 to 1.
2, right? Because if I double my circles, I need to double my squares.
When there are 4
So that would be
circles,
equal to 4 to 2. Now,
there
what
are 2
if
squares.
I put 6
the ratio
circles?
of circles to squares
Alex,
is
how
4
many,
to 2.
squares would I need?
4?
Ooh, close. How do we go from 2 to 6? What would we
Or
multiply
2 to
by?
1.
No, 3.
So we need 3 squares.
When there are 6 circles, there are 3 squares.
So the thing is, I can take 6
The ratio of
thirds
circles
and
to squares
reduce
is
it
6 to
down
3.
to 2 over 1, which makes it proportional. So proportional relationships always
Or
have that
2 to
same
1.
reduced fraction value. Does that make sense here?
Each
That'll make
ratio,
even
number
more
of
sense when you
circles
see it in
number of
the
squares.
table. So look at that table there that you have for side length and perimeter. Now, who can remind us how we find perimeter?
Isn't it?
Hearing?
You add? No, multiply.
Yes to both, but it depends on what you're going to follow that with. So we could add or we could multiply, but give me more information.
Oh my gosh, I don't know.
So perimeter of a square. I'll make it easier. We're dealing only with squares and we want perimeter. Are you passing?
Oh, yeah.
Alpha? Haley?
It's width times height. It's like how many?
That's area. You're actually the next problem ahead of us. So hold on to that. Remember that for the next problem. Nick? Add up the lengths of the side. More specifically though, in a square, what do we know about each side of the square?
It's even.
It's going to be the same, right? They're all going to be equal. So my perimeter here, I could just say I have 4 sides. So to find the perimeter, I could just do 4 times s. So look at this. If my side length is 1, my perimeter is 4 because I have 1, 1, 1, and 1. If my side length is 2, and I have 2, 2, 2, and 2, what's my perimeter? 8. If my side length was 3, what's that make my perimeter?
12.
12. Remember, we have 4 sides. Each side is 3. Now they flip it around for us. Please make sure you're filling this out in your notes as we're going, because you want to refer back to the notes when you're looking at your homework. So if my perimeter was 16, what would that mean my side length would have to be, Ty?
Because the last one was 3 and 12. Just 12 is 16 is 4 more than 12, and we're doing it by 4, so it'd be 4.
Yeah, because 4 times 4, or 4 plus 4 plus 4 plus 4, will give you the perimeter of 16. Now, if my side length is 5, what would that make my perimeter?
10.
Remember, we have 4 sides of 5. It's 20. And if my perimeter was 24, Colin, what's my side length? 6. So now, here's where we check if it's proportional. Look at this ratio right here. It's telling us what to do. It's going to be the perimeter divided by the side length. So we're going to take the perimeter, 4, put it over the side length, 1, and then try to reduce if we can. We can't reduce 4 to 1. It's already reduced as far as it goes. So they set up 8 over 2 for us. that reduced down to 4 to 1. So go ahead and set up your other ones.
Oh, okay.
You want to put your perimeter over your side length. So try to do it on your own, but look up here as you need to.
Would it be 12 to 3?
It'd be 12 to 3. And when I reduce by 3 on top and bottom, I get 4 over 1. So we are still proportional because they're all still equal, but we need to check all of them. So guys, especially if you're sitting up on a desk, please make sure you are taking the notes as we go. If you can't do both, you'll sit back down on a desk. So 16 to 4. Yeah, which when we reduce that, 4 over 1, everything still matches up to this point. 20
4 over 1.
to 5 reduces to 4 over 1. And 24 to 6 also reduces to 4 over 1. So, since each of these ratios comes out to be 4 over 1 when reduced, this is proportional. Ran out of board there. So, the other way to know this equation up here, 4 or P equal to 4S, my perimeter equal to 4 times S, I could also write that as Y is equal to 4 times X. Y is a multiple of X. Whenever you see something in this form where Y is equal to a number times X, it is proportional. So this equation right here, P equal to 4S, that tells me it is proportional because my perimeter is just a multiple of the side length. Make sense?
Yes.
Questions? Okay, let's look at area. So, Haley, how do you find area of a quadrilateral four-sided shape? Haley.
Width times height. Sorry,
Yeah.
I forgot.
The width times height or length times width or whatever you want to call it. It's your two side lengths. I like to use length and width just because because it doesn't look like a 1 then. So in mathematics, I had to differentiate what's a 1, what's an L, what for my brain, I have to do that. Otherwise, I will think it's a 1. So thank you, Brian. It's a cursive L. I know most of you guys don't have to know cursive, but that's a cursive. Well, you don't have to use it. All right. So the thing about a square,
I like your L.
the length and the width are the same. So it's really the side length times the side length. And really, a number times itself. Anyone know what it's called when you have a number times itself?
Yeah.
Oh,
It-
wait. It's.
Wait, Ben? That's a number divided by itself. Colin?
Was it square root?
Ooh, you had the word in there, but you kind of had too much. Nick?
It's squared.
It's squaring. That's why we do this with a square. The area of a square is the side length squared. Something times itself is called squared. So because we have two of them and they're multiplied by each other, we use the power of 2. Yeah.
No, this is just random, but how do you tell the difference of a square on top and an exponent?
That is an exponent actually. So a square, a square is the second exponent. There's other exponents. There's third, fourth, fifth. You can have any exponent you want, but because it's the second power or the second exponent, that is specifically called a square. If we had something to the third power, that would be called a cube.
Whoa.
And then from there, we just kind of say fourth or fifth or sixth, or we kind of just go with the numbers then. But so yeah, we have squares and cubes, and we'll talk about cubes when we get to volume. Right now, we're just dealing two-dimensionally.
Okay.
So if I have a square with length 1 and width 1 or height 1, 1 times 1 is 1. So now what about side length of 2? If we did 2 times 2, so go ahead and keep filling out that table on your own. The area is going to be the side length times itself. So we say that this is S, and this will be S times S. Then once you get those filled out, set up the ratios and see if all of the ratios match each other. doesn't mean the rest of it. So you need to erase all of these. And even this one. The area is 1 and 7 is 1. Don't make assumptions, guys. You gotta work out the work as it tells you. It's great. So area is always going to be like in a square. It's going to be the side length times itself. So the area for a square with length 2 is going to be 2 times 2. So then 4. So this will be 3 times 3. This is 9.
Finish.
You made an assumption. They don't match at all. Because it's area compared to side length. Area here was 1, side length was 1. Here, area is 9, side length is 3. Area is 16, side length is 4. Be careful not to make assumptions on these things. By the way, before we move too far, I forgot I wanted to pop over here because I had things in my notes. In your notes below the first table, you want to put that yes, this was proportional, and you can put because all ratios are equal.
Hey, I read because like that too.
Now, if we're asking you to write in complete sentences for like a short answer response, you don't want to abbreviate because. But if you're just writing quickly, like in the middle of class, you're just taking your notes that are for your use, you can shorthand anything you want as long as you can remember it. So I often put because as BC or B/C. So if we go back to our area, 3 times 3, what would be that area? Alex?
6.
You did plus. We got to do times.
Oh, whoops,
3
9.
times 3, yup, 9. If my area was 16, my side length would have to be 4 because 4 times 4 gives you 16. If my side length is 5, Sam, my area is 25. And anyone who knows that if my area is 36, my side length is 6. You can kind of make that assumption because how the table is going.
3 times
A
5.
lot of you had this wrong on the bottom row. We want area over side length. So Ashley, what should my first ratio over here be? 1 over 1. Because my area is 1, my side length is 1. Alpha, what about my ratio here for the 3 and the 9?
3 over 1.
Ah, give it to me not reduced first.
9 thirds.
Yeah, 9 over 3, which when I reduce it, then it becomes 3 over 1. Ashley, what about my next one?
16 over 8.
Ooh, wait, 16 over what? Your side length here needed to be 4, so check that that's right on your notes now. So it's 16 over 4, Colin, do you know what that reduces to? 4 over 1. You want to give me the next one since you only did half of that? What's my next ratio to start as? 25 over 5. What's that reduced to? Yeah. 5 over 1. And Alpha, bring us home. 36 over 6, which reduces
6 over 1.
to 6 over 1. So, when we compare these ratios with each other, 1 over 1,
Haley Dowdy to the office, please.
2 over 1, 3 over 1, 4 over 1, 5 over, oh, come on, give me my highlighter back. 5 over 1 and 6 over 1, are these proportional? No! None of these ratios are the same. Not only do they not, like, guys, they could all be the same except for 1, and that would ruin it. But not only is there 1 different here, each ratio is different. So on your notes here, you want to put that no, they are not proportional because the ratios are different. Or because the ratios are not equal.
Because all ratios are not equal.
Oh, that's cool. We start writing at the same time.
Questions on this? All right, so now you have a few examples to try. We're going to do the first. Huh?
Yes or no?
The second one was no.
No,
because the ratios are different or they are not equal.
A table
So
can be
our
used to show a
tables now,
proportional
whenever you're
relationship
setting up
between
the
two
ratio to check
quantities.
equivalency, you always want to make that ratio be y over x. And now I'm actually going to stop the video because I'd rather us solve it. So you always want it to be y over x. Might as well just write it. So, the other thing, and actually write on your notes, we can actually just jump to your notes and do it all here. What we're looking for with these tables below is actually our formula, and I would write this right here beside what about the tables below. We're looking for something to be y equals m times x, bless you, where m is a number. It's got to be a multiple, so m has to be a number.
M equals. Wait, can you put in any number?
You'll see here in a second. So for now, just stay with me, and then we'll see. After we do the first table, you'll understand.
Okay.
Because y has to be x times something, or something times x, and that something has to stay the same for each situation. So if we look at table 1 over here, the one on the left, y is what times x? Y is something times x. No?
Wait, 2.
2 times, right? So right here, my ratio of y over x would be 2 over 1. Here, my ratio of y and x is 4 over 2, but that can reduce to 2 over 1. Still, 4 is double my 2. Guys, if I was you, I would draw these arrows because it helps you see what we're looking at. Can you go from 3 to 6 by multiplying by 2?
Yeah.
Can you go from 4 to 8 by multiplying by 2?
Yeah.
Since all of these use that same rule, we can say y is 2 times the x, and that means that yes, it is proportional.
Then what is x?
It doesn't matter what we plug in for x. No matter what x is, y will be
Should I
double.
send car to the office, please?
So no matter what x is, y is going to be double that. So here, if I plugged in x to be 47, we would just double it to get our y. If x was 952, we'd just double it to get our y.
0.
Then y would be 0, because double 0 is 0. And actually, you're on the next lesson. You're already thinking about proportional graphs, which is great. But that 0, 0 point, that tells us that it's a proportional graph. So that's awesome that your brain's already thinking that far ahead. So we're going to do one more together, then I'm going to let you guys do the last 2 on your own. If I think about how y compares to x, and I set up that ratio 4 over 8,
Divide.
what do we get? When I have 4 over 8,
2 over 4.
and 2 over 4 could reduce further into 1/2, right? I can divide the top and bottom by 2, or by 4, and get to 1/2.
Wait a second.
Remember, we're going to do y over x. Every time we set up these ratios, it's going to be y over x. So here, to do my y over my x, it'll be 3 over 6. Guys, I would definitely be writing this down. It will help you with your homework. What does 3 over 6 reduce to?
1 over 2.
1 over 2, right? Now here,
Reduce to 1.
huh?
Why would 4 reduce to 1?
Because on top we divided by 4 and got 1, and on bottom we divided by 4 and got 2.
Wait, then why are they different?
They're not, they're the same. These fractions are equal to each other. This 1/2 is just the reduced form of 4/8. Because think about a pizza. If you have 8 slices total and you eat 4 of them, you've eaten half of the pizza.
Yeah, because
Does that make sense?
But won't
So-
it be 2? If you ate half?
You're thinking 8 divided by 4.
Oh.
We have 4 over 8.
Okay.
That makes no sense for fraction.
What do you mean?
Fractions.
I don't know what you mean by it
Like,
makes no
like
sense.
A 1 over 2 and a 1 over 4.
Oh, this next one. So we want y over x, which is really y divided by x. So if we take my y of 1/4 and divide it by my x of 1/2, well, remember, if I have a fraction divided by a fraction, we want to
I have the same dollar amount.
Keep change flip.
keep, change, flip. Thank you, Alpha.
Is there D to P on decimal?
Not right here because we're not dealing with decimals. We're dealing just with fractions right now. So I change my division to multiplication, flip my second fraction. I get 2 over 4, which reduces to 1/2. You can also think 1/4 is 1/2 of 1/2. If you have a pizza and you have half of it, half of that half is 1/4. So this ratio is still 1/2. And then think about 11 times a half. Because remember, we're hypothesizing right now that y is 1/2 of x. Half of 11 is 5.5. So this table is also proportional because y is just 1/2 of x. And guys, we get that multiple from the ratio of y over x. So what we're really looking for here, what we want, is an equation where we can say y is equal to this ratio. The multiple will just be the y divided by the x, and then we multiply it by x. I know it's kind of confusing, but that's how we get that number. That multiple is just the ratio of our y divided by our x. So try the third and the fourth tables on your own.
Wait, can we?
I will walk around to help you guys if you
Can we
need.
do the last problem?
We have 2 more.
No,
The get it? The got it?
no. Do you see 11 and then 5?
I just talked about that.
Oh.
So if we think about y being half of 11, I break 11 up into 10 and 1. What's half of 10? 5. What's half of 1?
0.5.
Half, right? So now I get 5 and a half. Y is half of x. Here, y is half of x. Here, y is half of x. Here, y is half of x. Because it holds true for the whole table, this is my equation. And yes, it is proportional.
Wouldn't half be half 1? Well, yeah, 1. Split 1. Wait, if you split 1, wouldn't
If you
it
have
be-
1 candy bar and you give away half of it, you gave away half of the candy bar. So this is also proportional. Try the third one and the fourth one on your own. If you're confused, stick up a hand. I will come help you. Gravity works.
Gravity works really
It
fast.
always works. Be careful picking it up.
Unless you were in
Gravity works.
Unless you were in the middle of nowhere, Kansas. There's no going on.
Try that. You want to set up the ratios of y over x. Off to the side of the table there, your y value divided by your x value. Yeah, so get that written down. You have 936. You need to be back in like 30 seconds.
So,
I'll defend my coffee with my life. I'm serious.
Wow.
I had a kid like knock my coffee off my desk and hit the ground. The lid popped up with full coffee. It stained the carpet and stuff. That was last year before we got new carpet.
You really wanted to say Mrs. Hammer.
No, that wasn't. No. It was,
Oh, I did it too.
well, yeah, but mine. That wasn't very full.
It was my own.
So when it was in the beginning of the morning, that's when I get really sad.
That was my own, I knocked it.
So you need to write down this work. You're not like see all the work that we've written down off to the side of the tables. So I'm gonna quickly jot some of that down for you. So you are wanting the ratio that we set up is the y value divided by the x value. So here your y value divided by your x value is 2 compared to 1. Then here this was 4 divided by 2, which reduced to 2 divided by 1. This was 6 over 3, which is 2 divided by 1. So that's how we do all that work. So you can do the same thing for this one, or the notes are posted. So for this one, we need to go on your own. We want to set up the ratios of y divided by x. So here my y value is 9, my x value is 3. What's 9 divided by 3? How many? Yeah, because threes fit into 9. When we set up this y value of 36 over 12, how many 12s fit in 36?
Now, how do you figure this out?
Now, these get a little bit harder. We're going to do them together. So I want you on this board. I want to try this out with ratios. See if they're all the same. Question or answer? Yep. We normally put the 3 or the number in front of the x. It doesn't matter. It doesn't change it.
took my paper.
Just we normally it just makes it nicer.
Wait, what happens if it doesn't go?
How are you gonna tell me
Then it's
something I
not.
didn't
Then this
do?
table's not
Sitting
proportional.
right here.
Like so. 3 divided by 4 was 2. Is 7 divided by 3 2? No. So since that's not 2, you know it's not proportional. Yeah, like at that point, you know it's not proportional. Because one of them being messed up makes the whole thing messed up.
Okay, so multiply cross.
Thank you.
12 over 9.
12 over 9, reduce that. 6 you get. Did you get? Yeah.
So set up your y value. No, other way around. It's y value divided by x value. Always do y minus x. So what's 9 divided by 3?
3.
Then we do 36, but no, not 1/3. It's just 3. Because you had 9 on top, 3 on bottom. You're going to end up with either a whole number or some number at least bigger than 1. Because your numerator's bigger. So about 36 divided by 12. That's the next one right now. And then how many 12s fit in 36? 12, 24, 36.
Oh, 3. And 1/3.
I'm going to do this
4
together.
over 9.
All right, let's do this together.
Okay.
Choose green. All right, so and some of you guys are choosing not to write down your work, and I'm telling you, you're only hurting yourself. The ratios we want to set up is y divided by x. It's always the y value over the x value. So my first ratio here is 9 divided by 3. How many 3's fit in a 9, Ben?
At least 3.
What do you mean at least? It's exactly 3. You're right, man. So, y divided by x, 36 divided by 12. What's 36 divided by 12, Alex? 3. Now, you don't have space here, but my y, 4/3 divided by my x, 4/9. I can keep change flip, so that will become 4/3 times 9 over 4. The 4's can cancel each other out. Now all we get is 9 over 3, and that can reduce to 3 over 1, or just 3. So this one again does equal 3, or 3 over 1. And then 4 over 1 and 1/3, I'll just tell you, is equal to 3. So yes, this is proportional, and your equation would be y equal to 3 times x. Not just 3, but 3 times x. Y is 3 times the x value. Any y value for that table would be triple the x value.
Do I put it at times where the X is right there? And then
Yeah, you can put a dot between them, or you don't have to, because if you have a number right up against a variable, you know it's multiplication. And my last table here,
4
we-
over 8 is 1.5.
so, well, not 1 and a half.
Well, 1 over 2.
Yeah, so it is 1/2. So if we do 4 over 8, that is 1/2. What about 7 over 3? Can that reduce?
No.
No. So is 7 over 3 equal to the 1/2 ratio?
No.
No, these are not equal ratios, so this is not proportional.
You can just tell by doing 1.
Just by doing the first 2 of them, they don't match, not proportional. You don't have to do any of the rest. Once they don't match, you're done. It's over. It's not proportional.
Over. And there's an easy way of telling that.
That's
There's
a
a
lot
easy
of
way of
writing.
telling that. You go like 2 problems back. thing.
Yeah, right. So here, again, y over x. So my first one, y over x, is 1 over 5. My second one, y over x, is 15 over 3. What's 15 over 3 reduced to or simplified to? How many 3's fit into 15? All right. 5. So this gives me 5, or 5 over 1. These ratios are not equal. They're trying to make you fall in the trap of thinking, oh, they both use a 1 and a 5. No. You can't use just the same numbers. It has to be in the same order. This one, then again, that one would actually give you 1 over 5. And then my last one here gives you 5 over 1 again. It is not proportional because they are not equal. So when we send copies to the copy center, it costs money depending on how many copies you get. So we have this next problem that shows the number of copies and the cost. Now we can kind of choose what order to go in. I think it's easier to take the bigger number divided by the smaller number because it'll give us a number bigger than 1 at least. So for your first one here, we're going to say that this is your y value and this is your x value so that we can do y divided by x because our ratio has to be y divided by x. So take your first value. Actually, I'm not going to draw arrows. You can figure it out. It's 150 divided by 18, right? It's $18 for 150 copies. So when I do 150 divided by 18, that we can actually use our calculator now. Because that doesn't reduce that easily. They could both be divided by 3 if you wanted. So if I divided them by 3, it'd be 50 over 6. But then that, I mean, they're both even. So we could get 25 over 3. If you just use your calculator here, you'd get, 8.3 repeating. So if you want to put it as a decimal form, and when you do the division, you get 8.3. Todd?
Wouldn't it be 0.12 in decimal?
What are you talking about? Did you do 18 divided by 150?
Yeah.
You did the division backwards. So,
Because I got 8.3333.
yeah, that's what we want. If you do 150 divided by 18, then that's when you get the 8.33. So, try 225 divided by 27. If I don't go through the process of reducing, if I just put it in my calculator, we get 8.3 forever. So those two match, but keep going. The next one, 550 divided by 55, that gives us 10. And then my last one, 1050 divided by 84, 12.5. Is this proportional?
No.
No! Your ratios come out to different values. Now, that might happen because when you go to places like FedEx or Kinko's or places where you're paying per item, a lot of times you will get a discount as you buy more. Hey, we're not done. We got one more. I've got at least a minute left. And half the time I'm waiting for you guys to get to my class because you decided to go to your locker or the bathroom or wherever. So if I occasionally run over by a minute or two, deal with it. We've got to cover what we've got to cover. So your resting heart rates. Now I've been walking around, I've been talking with people. Right now I'm at 105. But that's beats per minute. So my heart would beat 105 minutes or 105 times per minute. This is beats per second. So set up these ratios. If I set up my beats as my y and my seconds as my x, well, I have 6 over 4, which can reduce to 3 over 2. I'll wait. If people aren't writing stuff down, I'll wait and we'll make this take longer. If we do my next one, actually I'm going to come to the right for this one then. I have 9 over 6. That can reduce to 3 over 2. My next one, 15 over 10. That can reduce to 3 over 2 because I divide by 5 on top and bottom, bless you. And the last one, 18 over 12, we divide by 6 on top and bottom and get 3 over 2. Is this proportional? Yes, because they all match. All my ratios are equal. Yes, they all match. Now I want to show you one quick thing before you leave class. You now, if you get at all confused about anything,